You know that feeling, right? That little bit of digital impatience you get watching an AI type out its answer, one slow word at a time. Well, that lag, it might just be on its way out. Today, we're going to dive into a totally groundbreaking new architecture called TiDAR, and it promises to make AI generation not just crazy fast, but also just as smart. So let's break down how it actually works.
So where does this come from? Well, it's straight out of the labs at NVIDIA Research. You know, the company that builds so much of the powerful hardware that's driving this whole AI revolution. And what's cool is they're not just making the engines faster anymore. They're fundamentally redesigning how the whole thing runs.
All right, so here's our game plan. First, we'll unpack the big problem, this classic trade-off between speed and quality in AI. Then we'll see how TiDAR is this amazing best of both worlds solution. We're going to look under the hood at its secret sauce, check out the mind-blowing results, and then wrap up with why this breakthrough is such a huge deal for all of us. Okay, let's dive right into the core problem here. Why do we have to sit and wait for an AI to think? Well, it all boils down to this fundamental trade-off, one that developers have been stuck with for years. Yeah, that super familiar, almost painful one word at a time thing. It's not a bug, it's actually a feature. It's how the highest quality AI models are designed to work. They're built to be incredibly deliberate, but that careful thinking, well, it comes at the cost of speed. This really breaks it down for us. You've basically got two main paths. On one side, you've got autoregressive models. We'll call them the talkers. These guys are super meticulous. They generate one token or, one word at a time, making sure every single new word fits perfectly with what came before. The result? Super high quality, but man, is it slow. Then on the other side, you have diffusion models, the thinkers. They can just blast out a whole block of text all at once, in parallel. It's super fast, but that speed often means the output is, well, a little less coherent, maybe lower quality. Think of it like a really careful, polished speaker versus someone just brainstorming out loud, really fast. So you can see the problem, right? The holy grail for AI has always been trying to get the lightning speed of a thinker with the incredible quality of a talker. And that is exactly what NVIDIA's TiDAR architecture is trying to achieve. I love this quote because it just nails the core concept, and it's pulled right from the title of their research paper. The whole idea is simple, but really profound. Let the model think, do its drafting, using that fast parallel diffusion method. But then let it talk to finalize its output using the super high-quality autoregressive method. So what exactly is TiDAR? Well, it's this clever hybrid architecture that somehow does both of these jobs at the exact same time. It drafts a whole batch of potential next words in parallel, and then, in the very same computational step, it verifies that draft with its high-quality autoregressive brain. And that's the key here. It's not one step and then another. It all happens together in one single pass. Okay, so how on earth does it do that? Let's get into the secret sauce. How does TiDAR actually pull off doing two completely different things at once? The answer, honestly, is just incredibly clever. The real magic, the core innovation, is this. It all happens in what engineers call a single forward pass. So instead of having one model make guesses and then feed them to another, more powerful model to check them, TiDAR is just one unified model that does all the drafting and the final output, all in parallel. This visual gives us a pretty good idea of what's going on. As the model is carefully verifying the very next token, that's the high-quality talking part, it's also, at the exact same time, using its other half to draft a bunch of future tokens. It is literally thinking ahead while it's speaking. It's amazing. But wait, how is this even possible without slowing everything down? Well, this graph here kind of reveals the magic trick. You see, modern GPUs are so ridiculously powerful that when they're just generating one little token at a time, a whole bunch of their compute power is just sitting there, totally unused. They call these free token slots, and TiDAR cleverly exploits all that spare capacity to do its parallel drafting work for free. It adds basically zero extra lag. So let's just break it down one more time. In a single pass, the model drafts a bunch of possible ways the sentence could go. At the exact same time, it verifies how many of those drafted words are actually the correct ones, and then it outputs that correct sequence, and get this, it already has the next draft ready to go. It's just this incredibly fast, super efficient loop.
Okay, so that's all the theory. It sounds great, but what does it actually mean in practice? Let's get to the results because this is where things get really, really exciting.
Just check this out. At its peak, the 8 billion parameter TiDAR model can generate almost 6 times more tokens per second than a standard model of the same size. We're not talking about a small improvement here. That is a massive, massive leap in speed. And this chart really puts it all into perspective. So if you look at the standard model, that's our baseline, 1x speed. The smaller 1.5 billion parameter TaNDAR model, it's already at a 4.7x speed up. And then, like we just said, the big 8 billion model just blows past that to nearly 6x. The efficiency gains here are they're enormous.
Okay, but here it is, the million-dollar question, right? All that speed is great, but does it mess with the quality? And this graph gives us a clear answer. No. Just look. Even as the speed up goes through the roof, the quality score stays right up there with the best-in-class high-accuracy models. TiDAR is actually breaking that old speed versus quality trade-off. So what does this all mean? It means NVIDIA has created what they're saying is the very first architecture ever to pull off this kind of crazy speed up without sacrificing quality. It closes that gap. This isn't just another incremental update, you guys. This is a whole new benchmark for what we thought was possible.
All right, so a faster, smarter AI is obviously great for researchers and developers, but what does it mean for you and me? Let's zoom out and look at the big picture here.
Well, for one, this kind of efficiency could mean running seriously powerful AI models right on your phone. No cloud connection needed. Imagine that. It could also mean real-time AI solutions for really complex problems, everything from scientific research to creating unbelievably dynamic video game worlds. For the huge data centers that run all this stuff, it means lower energy costs, a smaller carbon footprint. But the most exciting part, it could unlock a whole new wave of AI applications that we haven't even dreamed of yet, things that were just impossible when AI was this slow.
And that really leaves us with one final, fascinating question to think about. For so long, AI development has been this constant balancing act, right? Do we make it faster or do we make it smarter? But with a breakthrough like TiDAR that basically says, hey, you can have both, what new frontiers, what unimaginable things can AI now go off and explore?